In this section, we will describe the 6 trigonometric functions. But before we can do that, we need to start the framework by talking about theta. And when we say theta, we're talking about an angle, and that angle must be in standard position. That means that our initial side has to be on the positive x-axis, and our origin will be where our vertex is located. We want to be able to pick any point on our terminal side. So here's our terminal side of our angle. We will pick any point that lives on the terminal side. So let's say that I pick this point here. We'll call that the point P, and this will be the x and the y value. So we have x and y, and we talk about r. R will be the distance from the origin to that point on the terminal side of the line that we have picked. Now, how do we find out what r is? Well, in order to find out what r is, we are going to we're going to take our point, and we're going to go straight down, and we're going to form a right triangle. Now we know what r is. R is going to be here. If you remember back, the r here would be the hypotenuse of this right triangle. What is this distance here? How would we describe that? Well, our point xy, leading up to that point, this would be our y value. So the distance of this blue line here, the vertical distance here, would be the y value of the point. The x would tell me the distance of this green line at the bottom. This right here is the distance from the origin in the x direction, so that would be the value of x. In order to work with this, we need to know how to measure r. How do we find out the length of r? In order to do that, since we have a right triangle, let's use our Pythagorean theorem. The Pythagorean theorem says that x squared plus y squared, which would be side 1 and side 2, the legs of this triangle, when I square them and I add them together, is equal to the square of the hypotenuse, which is r. So we'll say r squared. If I want to solve for r, we would take the square root of both sides, and now we know the measure or the value of r. R will always be positive because it's the distance from the origin to that point that we picked on the terminal side, and we are not allowed to pick the vertex of our angle or the point of origin as the point on the terminal side of our angle. So r will always be greater than 0. Now we can define the 6 trigonometric functions. We have sine, which we abbreviate as sin. That is a function name. So we have sine of an angle theta is equal to the ratio y divided by r. Cosecant, right below it, is abbreviated as CSC. That's our function name. Cosecant of the angle theta is equal to r divided by y. We have to be careful there. R is never 0, but y could be 0. So we want to make sure that y is never 0 for this particular function. Cosine is abbreviated COS. Cosine of the angle theta is defined as x divided by r. Secant is the reciprocal of cosine. Secant is abbreviated SEC. Secant of theta is equal to r divided by x. We want to make sure that x is never 0. Tangent, we abbreviate that TAN. Tangent of the angle theta is equal to y divided by x. We want to make sure that we never allow x to be 0. Cotangent is abbreviated COT. cotangent of theta is equal to x divided by y. We want to make sure that y is never 0. In our first example, we want to find the 6 values of the trigonometric functions if we have an angle theta in standard position where the terminal side of that angle passes through the point -12, 5. So we'll say that this would be our x value of -12 and this would be our y value of 5. If we have an angle in standard position, that means that we have our vertex at the origin and our initial side would lay on the positive x-axis. And we want our terminal side to pass through the point -12, 5. So there's our angle in standard position. This would be our angle theta. Now in order to find our 6 trig functions, we need to know what x is, we need to know what y is, and we need to know what r is. We already know that x is -12 and y is 5. Now we need to find r. Remember that r is the distance from the origin, that vertex, to the point that we picked that lays on the line, that lays on that terminal side. So r, we said, was equal to the square root of x squared plus y squared. So we need to simplify that. In order to do that, we need to figure out what is -12 squared. That would be 144. 5 squared would be 25. R would be equal to the square root of 169, and the square root of 169 would be 13. So we know that R is 13. So let's go over here and form the 6 trig function values. Sine of an angle theta, we see above here that sine is y divided by r, and our y value is 5. So that would be 5, that's my y, divided by r, which is 13. So sine of theta is 5 divided by 13. Now cosecant is the reciprocal of that. Cosecant is r divided by y. So we just flip that fraction. We get 13 divided by 5. That's our r over y. Tangent of theta is described as y over x. So we're going to form that fraction. Y is 5. And we want x. X is -12. So tangent of theta for this angle would be a value of 5 divided by -12. Cosine of theta is x divided by r. Our x value is -12. Our r is 13. Secant of theta, secant is the reciprocal for cosine. So our reciprocal would be 13 divided by -12. So it's the reciprocal. And cotangent is the reciprocal of tangent. It's defined as x divided by y. Our x value is -12, and our y value is 5. In example 2, we are told that the terminal side of an angle theta in standard position passes through the point -2 times the square root of 3. That would be our x value here, comma, -2, and -2 would represent our y value. Find the values of the 6 trigonometric functions. Now that x value, if we put that into our calculators, we put it in 2 times the square root of 3. we will find that that is approximately negative 3.5. So if I'm trying to figure out where to plot that, we would go about 1, 2, 3, 4. So I go about right here. That would be my negative 2 square root of 3 approximately. And we have a y value of negative 2. And just get an approximate idea here. And so that point would be right about there. So we have our angle in standard position. So I'm going to put my vertex at the origin and my initial side here on the positive x-axis. And then my terminal side will go through that given point. And here is our angle theta. Now, in order to find our 6 trig functions, we need to know what x is, and we know that x is negative 2 square root of 3. Our y value is negative 2, and r, remember that r is found by using the formula square root of x squared plus y squared. So r is equal to the square root of x squared, so that's negative 2 square root of 3, all of that squared, plus y squared. And now we need to simplify underneath. So r is equal to, now when I square, let's come over here, when I square negative 2 square root of 3, remember that's just multiplying that times itself. And you multiply outside number times outside number, so that gives me a positive 4 square root of 3 times the square root of 3, square root of 9, and we know that the square root of 9 is itself 3. So we get 12. So come over here and put in place of negative 2 square root of 3 squared, we'll put 12. And then we know that that would be 4. 12 plus 4 is 16. And so r would be equal to 4. So the first step is finding out what is your x, and what is your y, and what is your r. Now that we know the values of x, y, and r, let's form the values of our 6 trig functions. Starting with sine, sine of theta is equal to y divided by r. So the value of that would be negative 2 divided by positive 4, and we always want to reduce our fractions, so the sine value there would be a negative 1/2. Cosecant is the reciprocal of sine, that would be r divided by y, so we end up with 4 divided by negative 2, which gives me a negative 2 when I reduce. Cosine is x divided by r, so that would be negative 2 square root of 3 divided by r, which is 4. And the outside values here have a 2 in common, so we can reduce that to give us negative square root of 3 divided by 2 as our cosine value. Secant is the reciprocal, so that would be r divided by x. R is 4, x is negative 2 square root of 3. And once again we can reduce this. 4 and 2 have something in common. They're both outside of the radical. So we have 2 divided by negative square root of 3. We can think about that negative as really being out front. Let's just go ahead and push that out front of our fraction. And we need to rationalize. If you remember back from college algebra and from previous days, we didn't want to have a radical left in our denominator. So to get rid of it, we're going to multiply top and the bottom by exactly the square root that's in the bottom. That gives me 2 square root of 3 over square root of 3 times the square root of 3 is the square root of 9. Don't want to forget that negative that's out front. So we end up with negative 2 square root of 3 all over square root of 9 is 3. So we want to simplify and rationalize all of our fractions before we decide that that would be our final answer. Tangent is y divided by x. Our y value is negative 2. Our x is negative 2 square root of 3. Once again, our outside values have something in common. That really gives me a positive 1. My negatives also cancel. So I end up with 1 divided by the square root of 3. And once again, I want to rationalize my answer. So multiply top and the bottom by the square root of 3. And our final answer here would be square root of 3 divided by, we see that the square root of 3 times square root of 3 is square root of 9 from before, which ultimately gives us a denominator of 3. And lastly, we have cotangent. Cotangent is a reciprocal of tangent. Cotangent is x divided by y. And our x value was negative 2 square root of 3. Our y value was negative 2. It's just the flip of what we started out with for tangent. We want to reduce. The negative 2's cancel. Leaves us with square root of 3 divided by 1, which simplifies just to be positive square root of 3. Now we will find the trig function values of specific angles. Here we will look first at the quadrantal angles. Quadrantal angles are angles in standard position whose terminal side lays on an axis. So if I'm looking for 0 degrees, remember 0 degrees, that would show no rotation. So that would be my angle for 0 degrees. When I'm finding trig function values, we need to know what is x, and what is y, and what is r. And when we go to pick, remember we can pick any point that lives on the terminal side. The easiest point that we could pick that lives on the terminal side of 0 degrees would be 1, 0. Now you could use 2, 0, 3, 0, 4, or anything in between, any fraction, any value. We're going to choose the easiest point, the simplest one to work with, 1, 0. So the x value of that point that lives on the terminal side, the x value would be 1, the y value would be 0, and remember that r is the distance from the vertex to the point that we picked on the terminal side of our angle. What is the distance here? And that's pretty simple. We could see that that would be a distance of 1. So now let's form our 6 trig functions, now that we know what x and y and r are. So sine, remember, is y over r, and that would be 0 divided by 1. Let's go ahead and just do that. So sine would be y over r, so we said y over r, that would be 0 divided by 1, which simplifies to just be 0. So we always want to simplify our fractions. Cosine is x divided by r, so that would be 1 divided by 1, which simplifies to be 1. Tangent is y divided by x, so that would be 0 divided by 1, which also simplifies to be 0. Cotangent is the reciprocal of tangent, so that would be x divided by y. And 1 divided by our y value of 0 would be undefined. Secant is the reciprocal of cosine. That would be r divided by x. And we see that 1, of course, is the reciprocal of 1, so that makes sense. What do you guess that cosecant would be if cosecant is the reciprocal of sine and the sine value is 0? The reciprocal of 0 would be undefined. So let's see if that turns out like we expected. Cosecant is r divided by y, and r divided by y would give us an undefined value. Now we're going to do the same thing, but this time we're going to work with our 90-degree angle. And our 90-degree angle, we're going to put that in standard position. So there's our 90-degree angle. And we want to find, once again, the x value, the y value, and we want to find r. So we can pick any point that lives on the terminal side of 90 degrees. So once again, we're going to pick the easiest point, 0, 1. So the x value of the point that we picked that lives on the terminal side would be 0. The y value would be 1. And our r, remember, is the distance from the vertex to the point that we picked on the line. Pretty easy to see that that distance would be 1. Alright, let's use these and form our trig functions for 90 degrees. 90 degrees has a sine value, let's say y over r, so we have 1 divided by 1, which simplifies to be 1. Cosine is x divided by r, so that's 0 divided by 1, which is 0. And tangent is y divided by x. So y is 1, x is 0, we get undefined here. Cotangent is a reciprocal of tangent, so that would be x divided by y, which is 0 divided by 1, which is 0. And that makes sense, that 0 and undefined would be reciprocal ideas of each other. For secant, that would be r divided by x. Remember, secant is the reciprocal of cosine. So what are we expecting our answer to be for cosine? If cosine is 0, we're expecting secant to be undefined. So let's see. That would be r divided by x, so that's 1 divided by 0, which is undefined. Cosecant is a reciprocal of sine. Sine is 1, so we're expecting cosecant to be 1. Cosecant is r divided by y, and r divided by y also gives us 1. Now let's find the trig function values for the next quadrantal angle, 180 degrees. So remember that 180 degrees, we put that in standard position. 180 degrees is a straight angle. It's half a rotation around, and we want to pick a point that lives on the terminal side of this angle. So can you tell me which point would you pick? What would be the easiest point to pick that lives basically on the negative x-axis here? Okay, we're going to pick -1, 0. Remember, once again, it does not matter which point you pick on the terminal side. All of them would reduce to be the values that we see here. So -1, 0 will just be the easiest, and that's what we'll pick. So we need to know what is x, what is y, and what is r. X is -1, y is 0, and once again, r is going to be 1. Pretty easy to see that that would be the distance from our origin to the point that we picked on the line. Sine, once again, hopefully you have this memorized by now. Sine is y over r, so that would be 0 divided by 1, which is 0. Cosine of 180 degrees, you know that's x divided by r, so x is -1, r is 1. So this simplifies to be -1. cotangent is y divided by x, so that would be 0 divided by minus 1, which would be 0. Cotangent is x divided by y, that's negative 1 divided by 0, which would be undefined. Secant, do you remember what secant is? Secant is r divided by x. Remember, it's the reciprocal of cosine. R divided by x. So that would be 1 divided by negative 1, which simplifies also to be minus 1. And that makes sense because negative 1 is its own reciprocal. So negative 1 makes sense for cosine and secant. Cosecant is the reciprocal of sine. Cosecant is r divided by y. R is 1, y is 0, so we get undefined. Okay, now let's go through this again one more time for our last quadrantal angle, which will be 270 degrees. So we're going to put our angle in standard position, and we are going to come all the way around 3/4, 3 quadrants, and we're going to be right here on the negative y-axis. We're going to pick a point, the easiest point again. Zero comma negative 1, and so we know our x is 0, our y is negative 1, and what is r? R is 1. Remember, it's the distance, and for all the quadrantal angles, the distance is very easy to determine. It's just a straight line. So 270 degrees, what are my 6 trig functions? Sine of theta, sine y divided by r. So we know all of these are y divided by r. Y divided by r is negative 1 divided by 1, which reduces to be negative 1. Cosine x divided by r, 0 divided by 1 would be 0. Tangent is y divided by x. So that would give us negative 1 divided by 0, which would be undefined. Cotangent is the reciprocal of that. That would be x divided by y. So that would be 0 divided by minus 1, which is 0. Secant is the reciprocal of cosine, so that would be r divided by x. It's 1 divided by 0, undefined. And then lastly, cosecant, the reciprocal of sine, that would be r divided by y. R is 1, y is negative 1, so we get negative 1 as our cosecant value of 270 degrees. Now, why haven't I done 360 degrees? Well, 360 degrees is coterminal to 0 degrees. We talked about coterminal angles. So 0 degrees would be no rotation, 360 degrees would be going all the way around one complete rotation. If I was to find the 6 trig functions for 360 degrees, notice we said 360 degrees and 0 degrees were coterminal. We would pick a point that lives on this terminal side of the angle, and that would be 1, 0. And guess what? That's the same exact point that we picked for 0 degrees because they have the same coterminal side. And if I form all my 6 trig functions, we're going to get exactly the same values that we got for 0. So 360 degrees and 0 degrees have exactly the same 6 trig function values. Find the indicated function values for the following. Our first problem would be sine of negative 270 degrees. So sine we know is y divided by r, so that's what we're looking for. So we need to know what y and r. So let's think about where negative 270 degrees would be located. So we put it in standard position, and we're going to go around in the negative direction. This would be negative 90, negative 180, we need 90 more, and we're going to stop here. We went 3 quadrants. Remember, each quadrant is 90, so it's 90, 180, and then 90 more would be 270. So we went 270 degrees in the negative direction. We can pick a point that lives on the terminal side. That would be 0, 1. So x is 0, y is 1, and r, once again, is also 1. So our sign value would be y, which is 1, divided by 1. So we get a final answer of positive 1. Now we want to find the tangent of 1800 degrees. Tangent is y divided by x. So I need to know what y is and what x is on the terminal side. So we're going to sketch our angle. Now I need to know how many rotations I have, and we could subtract 360 several times to figure out how many times I have a complete rotation, because 1800 is definitely more than one rotation. We're going to do a little bit of a shortcut here. We're going to do 1800 divided by 360 degrees. I want to know how many times 360 goes evenly into 1800. divided by 360 is 5. So this means that I have 5 complete rotations of my angle. So 1, that's 360, 2, 3, 4, 5. 5 complete rotations. So our terminal side actually lays right there on the positive x-axis. So I can pick a point that lives on my terminal side, which would be 1, 0. All we need is to know is x and y. My y is 0. My x is 1. So we get a tangent value of 0. Now cotangent of 540. Cotangent is x divided by y. So we want to graph 540. This is a relatively small value. So if I subtract 360, you see that we have to go 1 complete rotation, and then what's left over is 180 more degrees. So when we put this in standard position, we're going to do 1 complete rotation, and then we're going to go 180 degrees more. So the terminal side of my angle lays right here, coterminal with 180 degrees. We're going to pick a point on our terminal side, which would be -1, 0, and we need to know x and y. X is -1, y is 0, and any number divided by 0, of course, would be undefined. Evaluate the following expressions. So we want to find tangent of 0 degrees minus 6 times the sine value of 90 degrees. So we need to remember how to find our tangent value. Remember, tangent is y over x, and we're talking about 0 degrees. So that will be our 0 degree angle in standard position. The point that we use to find our x and our y would be 1, comma 0. X is 1, y is 0. So that would be 0 divided by 1. And so the tangent value of 0 would be 0. Minus 6 times our sine value. So we want to find the sine value of 90 degrees. Okay. $90 degrees in standard position. Our terminal side would be pointing straight up, that positive y-axis, so 0, comma 1 will be our x and our y value that we would use. Sine is y divided by r, and remember that the r would be 1. So y divided by r, so y would be 1. R is also 1, so that would be 6 times 1. So 0 minus 6, when we evaluate the overall expression, our final answer would be negative 6. For part B, we're looking for cosine squared of negative 180 degrees plus sine squared of negative 180 degrees. So we just need to find where the terminal side of negative 180 degrees is going to stop. And I'm going to go negative 90, negative 180. So it's a half rotation in the negative direction. We want to pick our point that lives on our terminal side, which would be minus 1, comma 0. So our x and our y and our r we know is 1. Just the distance here will be 1. So cosine, we know that's x divided by r. And when we say cosine squared, that means to find the cosine value of negative 180 degrees. And then after we find that value, then we are going to square it. So that means the same thing. Cosine squared of negative 180 degrees. We want to find the cosine value of negative 180 degrees and then square it. So this is two different ways of writing the same thing. So what is the cosine value of negative 180 degrees? Well, that would be x would be negative 1 divided by r, which is 1. Well, negative 1 divided by 1 is negative 1, and when I square that, we get a positive 1. Now we're going to do the same thing with sine squared. Sine squared of negative 180 degrees, so we want to find out what is sine of negative 180 degrees, and then we want to square it. So sine is y divided by r. So that would be 0 divided by 1. And then we square it. Well, 0 divided by 1 is 0, and 0 squared is 0. So 1 plus 0, of course, so our final answer there would be 1.